All right, happy Monday, everyone. So today we're going to continue our process of solving systems of equations by substitutions. You see with the first problem, we have a system of equations, 2x plus 8y is equal to 20, and then that same y is equal to exactly 2. So we already know one of the two parts of our solution. And so when we write the solution, remember we're writing an x then a y. So I don't know the x yet, but I do know that the y is equal to 2. If it's equal to 2 in one of the two equations, it's also equal to 2 in the other equation. So all I have to do is take out the y in that equation and substitute in a 2. What you have to remember is that the 8 is being multiplied by y. So when I rewrite the first equation, I write it as 8 times 2. Okay, and then I have 2x plus 8 times 2, which is 16, is equal to 20. And now we're solving by undoing. Always undo the addition or subtraction first. Take away 16, take away 16. And I end up with 2x is equal to 4. And divide by 2, x equals 2. So it just so happens that they are exactly the same. Okay, and you can figure it out without having to go through the entire process. You can say, okay, once I get the 16, what do I need to do from there? Okay, so when you see that it's 2 times some number plus 16, well, you know that to add to 16, what do you have to add? You have to add 4 in order to get 20. How do you make a 4 by multiplying by 2? The only number you can multiply by 2 and get 4 is 2. So you can do it that way. That's perfectly fine. Okay, I want you to do number 2 on your own. Remember this time, though, that we're substituting x in. So it's not always the y. It's, in this case, we're replacing the x. But we already know what x is equal to. Okay, so you finish number 2. Number 5, same idea, except now it's not y equals a number, it's y equals 2 times x. So that's what I'm substituting in for y. Okay, so 5x minus 2 times 2x equals 3. I have 5x minus 4x equals 3. And 5 take away 4 is 1x or just x. So now I know exactly what x is equal to. Okay, I've got one part of the solution, that's 3. I don't know what y is yet. So I take that value and I bring it back up and I substitute it in for x in one of the two equations. And it doesn't matter which equation you substitute it in. Second one looks like the easiest, so I put it into that one. 4x, because all I'm doing is multiplying the x times 2, and that gives me 6 for y. And that is my solution. Okay. Same thing with number 4. Number 4 is yours to do. So, but remember, we're substituting that in for x. And in this case, there's nothing to multiply by it. We're just putting 3y in there. Okay. And again, you can pause in between and try those other problems, or you can do them afterwards. It makes no difference to me. Whatever works best for you. Number 5 gets a little bit more complicated because we're setting y equal to x plus 9. So I got to substitute that in. So I replace the y. I'm not replacing the 7, and the 7's being multiplied by whatever y is. Since it's more than one thing, I'm adding 2 terms together, x plus 9. I have to put that in parentheses. And then I distribute. So the 4x didn't change. 7 times 1x is 7x. Oops, I forgot to put what it's equal to. 7 times 9 is 63. And 4 plus 7 is 11x plus 63 equals 19. Take away 63, take away 63. Again, this is part of the solve by undoing. So I have 63 minus rather 19 minus 63. Really, you can think of that as 63 minus 19, but keep the negative sign. That gives me 44. Why do we keep the negative? Because the negative 63 was larger than the positive 19. So we keep that negative sign. Then we divide by 11, and we get x is equal to negative 4. Got to be careful with your positives and negatives. Makes a huge difference. If I were to take x equals negative 4 and plug it in, as opposed to x equals positive 4, then it would make a big, big difference. All right. So now I have to take x is equal to negative 4. I already know one part of the solution. Negative 4, comma, we don't know the y yet, so I've got to take it back up and substitute it in for x in one of the two equations. Y is equal to x, or negative 4, plus 9. And when I take negative 4 plus 9, that's the same thing as 9 minus 4, and that gives us 5. You should have all been envisioning that answer in your head. And so there is my solution. Okay, same process with number 6. I want you to try that one on your own. The 6x plus 11 is going in for y. So we're replacing it, but remember we're multiplying that by 2. Okay, so you solve that one on your own. Next page. There are 3 pages, but there's not a lot of problems. I think there's 10 problems, and the 11th problem on the last page I want you to try. I'll give you a suggestion for trying that problem. Okay, number 7. Y is equal to negative 7 minus x, so we plug that in for y. So I have 2x minus 8y equals 6, which is 2x minus 8 times negative 7 minus x. And it doesn't matter what the order is. You could switch around the negative x and the negative 7. It makes no difference. But we're distributing. Anytime we see a set of parentheses, that's what we need to think. So I have 2x plus, negative times negative. 8 times 7 is 56. And positive 8x. Now I have like terms, clear over here and over here. So I have 10x plus 56 equals 6. Take away 56 from both sides. I get 10x here. Again, those zero out. And 56 take away 6 is 50, but because the 56 rather was negative, we keep the negative sign. Now I divide by 10 on both sides, and I get x equals negative 5. I know what x is, but I don't know what y is. So I take that up and I replace it. And again, it does not make a difference which equation you put it in. This time I'm going to put it in the first equation, which is 2x minus 8y equals 6. And so that's 2 times negative 5. Take away 8y equals 6. 2 times negative 5 is negative 10. Add 10 to both sides. That zeroes out. I get negative 8y is equal to 16. And divide both sides by negative 8. Make sure you divide by the negative. And I get y is equal to negative 2. So my solution, x is negative 5, y is negative 2. Okay, if you need to, pause the video. You do number 8 on your own. And number 9, again, they have it set up so that we have y by itself, so it's 3 minus x. We substitute that in to the second equation for y. So I'm going to put that in place of y. 3 times 3 is 9, and 3 times negative x is negative 3x. So I have negative 3x and positive 1x. Those two go together. That gives me 9 minus 2x. Again, 3 minus 1, keep the negative sign. Okay, now, a lot of people get confused here. Remember, we're trying to get rid of the number that's added or subtracted from the x term. So this is technically negative 2x plus 9, so we want to get rid of the 9. We subtract from both sides, we get negative 2x equals negative 4, and then we divide both sides by negative 2. Okay, those two are gone. They won out technically. Negative 4 divided by negative 2 is positive 2. So I have part of my solution. Positive 2, comma, and then I just take that number and substitute it back in. Again, makes no difference which equation you put that in, but I'm going to put it in the second. The second says to take 3 and subtract whatever x is. Well, x is 2, so we're going to subtract 2, which gives us y equals 1. Number 10 is yours to do. Make sure that you go to the last page. The last page has a hardcore problem. Okay, I'm going to give you a suggestion. One of these two equations you can divide by a number that will get a variable all by itself. That is our goal. We want one of the variables all by themselves. So think of a number that we can divide everything by, not just one term, but every term by, to get one of the two variables, either x or y, all by itself. Okay? But make sure you divide each and every term by that value. Okay? Then once you get that by itself, whatever that's equal to gets substituted in for that variable in the other equation. I'll let you try this one on your own. Good luck and have fun.